Hello, this is Hind Hamad, and I'm going to be talking to you about my Pokemon card price analysis tool that I made. The idea was to discover or find out what the price of a Pokemon card would be, or kind of predict it. But in this case, I also wanted to understand what factors drive these prices, not just get a price. Uh, so we first started with, installing the all the imports and getting the data, looking over it. I found that some it had some like the rarity, how rare something is, its HP, the Pokemon card in this case, the artist, the year. And regarding the data quality check, I did a bunch of checks. The missing values, there were none, duplicates, none. I also did some additional ones because there was nothing on the other ones. I checked for negatives, zero values, nothing. All I've noticed is that there was price outliers. In this case, it was very right skewed. I'm not sure if I said it right, but where most cards had lower values in this case, and a very small amount of number of cards had very high values. But in this case, I didn't want to fix that problem because it was so essential. Having these outliers, they weren't just outliers. In this case, it represented how rare the card is, the better cards. So I had to keep it as is. Other than that, the super type contained one value for all, so it didn't really make sense for us to have it in the analysis itself. Moving on, what did we discover from the EDA? We discovered that the artist information was included because of how important it is, and in this case, the most important factor was how rare it is. Let me open to you here. So the rarity factor was the most important factor that changed the price, as well as the artist. Last is the card HP. It didn't really make any sense to have it in there. It was the weakest factor. Moving on to save time, what model I used. So other than the EDA, I got a bunch of some peer review from my friend, and I did change a couple of things based on that. Then I decided to go ahead and use where is it? Let me show you. We reviewed like feature structure to just like to be able to know exactly what was influencing these differences and these changes. In this case, we discovered the rarity is the most influential part. And I have all of the graphs for it here. You can check it out later. For now, just to be faster, I also made I split the data set after preparing it, after changing categorical values, in this case the year to numbers instead of category. And then I did linear. I chose the regression because the goal was to estimate a numerical price value, USD dollars, rather than classifying cards into categories. I also ended up doing a bunch of tests on them and found out that the best one was the one with the gradient. So I did gradient boosting because the Pokemon card values depended on multiple interacting features, not just one. Unlike the simpler linear model in this case, it showed that the gradient boosting can actually capture more complex relationship between the features of like rarity, artist, set information. The gradient boosting also builds multiple small decision trees, so each tree focuses on correcting the errors made by the previous one. That's why it had way better than linear regression, which I tried, and random forest regression. I tested these theories based on the MAE, which basically tells you like if it's equal to 5, then it means that the model is off by $5 on average each time. I also tested it based on the RMSE, which gives you the more importance of like the large errors. In this case, it's very important for the larger number, the expensive cards. And the R2 here explains how much the variation in the card prices can be explained. I have everything I have everything documented here. Other than that, let me move faster. Yeah, so I found out which parts. I also made the Streamlit app. In this case, it's right over here. You can try out predict a price. You can even move on to check out my data analysis, what I discovered, and what I would choose or what limitations I had. The data set had only 1,000 cards, so it wasn't that much when it comes to calculating or coming up with a perfect model. I also, if I had more time, I would even add more. I would add more than these factors, and I would get rid of the HP because in this case it didn't really do much. As you can see, it doesn't really change a lot. So I would completely ditch the HP and focus more on the other factors. Yeah, that's it for me. Thank you. I hope you enjoyed this video.